sines. Okay, also in this section is the law of cosines, but we're going to cover that on another day. So first of all, we need to define what an oblique triangle is. An oblique triangle is a non-right triangle. So up until this point, we had used the trig functions to solve right triangles. We'd use sine, cosine, and tangent. Remember, we had opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Well, what we're going to do today is what happens if it's not a right triangle. What happens if it's got angles of 60, 70, and 50? Okay, how do we solve those triangles? And so we actually have two ways to solve oblique triangles. We have the law of sines and we have the law of cosines. Now notice in parentheses I have some of these letters, and hopefully you'll remember what they mean. But in parentheses for the law of sines, we will use the law of sines when we know angle, angle, side. Okay, remember that from geometry? And then angle, side, angle. And then side, side angle. And this side, side angle is one that we will cover tomorrow. This is actually a special case. We call that the ambiguous case. Okay? You don't write it the other way. You write it side, side angle. And that's what you call it. You say side, side angle. Okay? So I see some people obviously did figure out what I was saying there. Okay? But then we also have the law of cosines. Okay? Law of cosines we will use when we know the side, side, side in a triangle, and then the side, angle, side in a triangle. Okay, oh, there we go. We got some other ones that finally figured it out. Okay, so anyway, let's go ahead and write down what the law of sines is. Now, you will see this written two different ways. Okay, this is one way. This is the way I've always done that. Okay, I do believe that some books will actually have them flipped, and they will write them this way. It doesn't matter to me which way you use. Okay, I've always used the one on the top, and so that's the one I'm going to use. But we will use the law of sines when we know angle, angle, side, angle, side, angle, and side, side angle, which we call side, side angle the ambiguous case. And like I said, we take a whole separate day just for that. Because I said that some books will write it this way. Okay, so. Okay. So we're just going to jump right in with an example. That's the best way to start, especially in this situation. And so if you notice, it says solve triangle A, B, C. Now when it says solve triangle A, B, C, remember from last chapter, what does that mean?
Find all the angles.
Find all the missing parts. So find all the missing sides, find all the missing angles. And generally, you're only going to have 3 that you need to find because they have to give you 3. So I know that angle C is 102.3 degrees. So I'm just going to draw a quick diagram. Okay. So I'll do angle C here at 102.3. Angle B, I'll just put angle B up here. No reason why I chose there, just because. 28.7. Now, when it says little b, do we remember where that goes? Little b actually goes opposite big B. So big B is the angle, so little b will be down here on this side. Okay, and then I have angle A. So what I'm missing and what I need to find are angle A, side A, and side C. And so let's just review really quick. Where would side A be if angle A is here? Opposite side, so right here, and then side C. So this is an oblique triangle. It is not a right triangle, so we can't use our sine, cosine, and tangent. So our next option is to use law of sines. Now when we use law of sines, we are looking for an angle-side combination that we know. Do we know an angle-side combination where we know both things? Yeah, no, I'm just asking in general. If you look at that diagram, what's the angle-side combination that I know? Okay. I know angle B, and I know side B. That's an angle-side combination, right? Okay, that's a pair that I know. So I'm going to start by writing the sine of 28.7 divided by 27.4. That is an angle-side combination that I know. Now, what I need to do now is I need to find what side. Okay, I do, but in this case, I don't want to find side A because I know this angle right here. So I'm going to find side C, sine of 102.3. So now this is a basic proportion. You need to make sure your calculator is in degree mode in order to do this. In order to do that, remember you go up to mode, which is right by the blue second key. Okay, you need to make sure that the third one down says degree, not radian. So on your calculator, what we need to do is we're going to cross multiply. So I want you to tell me, first of all, what's the sine of 28.7 to 4 decimal places?
4802.
Somebody else get 0.4802? Okay, so I know 0.4802 times C equals, I need you to multiply 27.4 times sine of 102.3. Now on your calculator, you can do that as one step. Okay, make sure this is what you type in. You type it in just as you would see it. And to 4 decimal places, what do you get? 26.7710. Somebody else get that? So now to solve that, what are you going to do?
Over
0.4802. And what do you get C to equal?
55.749.
So 55.75, right? Okay, so that's what side C equals. That's one way. Now if you want to, there is another way to solve proportions and do this in one step. How you would do that? You multiply along the diagonal, so you take 27.4 times 102.3, and then you divide by sine of 28.7. Okay, so if you remember that way to solve a proportion, you multiply along the diagonal and divide over. Great, you can use that. If not, once again, throw that out. Okay, so now I need to find angle A and side A. So let me think, how can I find angle A? Add the two together and subtract from. So go ahead and do that. So basically, if you didn't catch what was being said, I'm going to take 180 degrees, which is the sum of the measures of a triangle. I'm going to subtract off 102.3 and 28.7. And what do I get for angle A? Even? Okay, so 49 degrees. So now I need to find side A. And so, last but not least, in order to find side A, I'm going to stick with that same angle-side combination I started with. Okay, and that angle-side combination, if you remember, was sine of 28.7 over 27.4. And I'm going to go ahead and put that equal to the sine of angle A, so the sine of 49 over side A. So once again, there are two ways to do this. One, you can do it in one step, in which case you would multiply along the diagonal and then divide by sine of 28.7. Or you can multiply here, and you would get 0.4802C. Oh, actually A, sorry, equals, and then whatever that multiplies to be. So I need to know what you've got for side A. What'd you get? 43.06. Did somebody else get that? Okay, 43.06. So that is what side A equals. And there you go. You've solved the triangle. Questions? Pretty straightforward? Let's look at another one. Now this one, they're not going to have it for you in words. They're just going to have a diagram for you. So instead of actually listing, you're going to now have to look at the visual and determine that you need to find angle T, you need to find side S, and you need to find side T. So the very first thing you're going to look for is an angle-side combination. So one pair that you know. And you know R, that's right. So based on the fact I know R, let's go ahead and start. So I know the sine of what? 63 over 13 equals sine of 51 over what? S, little s. Okay. So does somebody have what little s is? Somebody else get 11.34? Good, I did too. All right. So now, is there anything else I know? Angle T. I can find angle T by taking 180 minus 63 minus 51. What do you get? 66 degrees. So last but not least, I need to find side T. Now, one of the things, if you're not big into wanting to write out the proportions, a lot of times what you can do is I can just get rid of that 51 right there. Do you see how I did that? And then replace that with 66. Oops, that's not a decimal, by the way. Replace that with 66 and then side T. What do you get T to be? 13.33. There you go. You solved the triangle. Okay, what do you think? Yeah, it's not too bad. It should be fairly easy because this is actually the easiest one of the three. So let's go ahead and look at this right here. It says a satellite is passing between Oak Ridge Lab and the Langley Research Center, which are 446 miles apart. If the angles of elevation, remember angles of elevation means you elevate. So I'm starting here at the horizon and I'm going up. If they are 58 and 72 degrees, how far is the satellite from each station? So really what I'm trying to find is I'm trying to find how far is the satellite from Oak Ridge, right here, and how far is the satellite from Langley, right here. So I need an angle-side combination in order to use my law of sines. So what's my angle-side combination? You can make one. Right now you don't have one that's given, but you need to make one. So I need to find what this missing angle right up here is. And what is that missing angle? 50. Because I already know this angle is 58 and this angle is 72. So if you subtract them from 180, you're good to go. So I now have my angle-side combination. Sine of 50 over 446.
So then you'll use that for both of them?
Yes. Once you find that angle-side combination, you will keep using that throughout the problem. You won't switch. So what will that equal? Sine of 58, yep, over, in this case, side A. A, over here. Okay, so what do you get? 493.74 miles from which one? From Langley, because that's what we found over here. So that's my first answer. Now what I need to do is find out how many miles it is from Oak Ridge. So in order to do that, I'm finding what?
Sorry.
72 over B. Okay?
Is this all of them?
Yes.
Oh, sweet. Yes.
So what do you get your answer to be? 553.72 miles from what? Oak Ridge. So the first one was A. Yep. And this one is B. So that is the law of science. Now it is imperative that you get this down and you know how to do this, because otherwise tomorrow you're going to be totally lost. Okay? And it's also imperative that you get this down, because then when I throw the law of cosines at you on Wednesday, you aren't going to totally be lost. Okay? So what you need to do for me, page 298, 1 through 9. Now this is actually one that you're going to add to tomorrow. Okay? But if I were you, I would get it done tonight. That way you don't have to worry about it, especially those of you that have volleyball tomorrow night. Okay? So,